Welcome back to the channel. This is the 8th video in a series on how to design a PRS guitar in Fusion 360. In this video, I'm going to review all of the cam strategies and cam toolpaths that I use to cut this neck on a CNC machine. If you like this video, please give it a thumbs up and consider subscribing to the channel. So let's get started. So here's where the model currently stands. We've got a neck, a body, a fretboard, and also a headstock cap. One thing that I did that's not in the videos is this headstock cap used to be a body inside the neck component. Now there's just a single body there. So what I did is I right-clicked on it and I made a component from bodies. Where is it? Here it is. Create component from bodies. And then I actually moved that component so that it's on the same level, the top level, along with the other components within the guitar. The reason I did that is to control its visibility during the cam work. So if you're not familiar with cam, or they now call it manufacturing, in Fusion 360, this is how you get to it from the big drop-down menu. And when you fire up manufacture, the most important thing are these setups. And basically a setup is just a series of toolpaths that you don't have to move your stock around in order to accomplish. So I've got 5 here. I'm going to go over the first 4. We're not going to get into the fretboard in this video. Now, you do activate a setup, same way as you activate a component, and you do want to activate it when you're working on it. One of the reasons you'll see is as I activate these different setups, you're actually seeing different stock and different parts of the neck model. And you're also seeing different views. The neck's actually getting flipped over here between the neck top setup and the neck bottom setup. So I'll explain what all these setups are, but I think the first important thing is always activate a setup before you work on it. And when you open up a setup, you'll see things below it. These are the individual toolpaths. And you can click on those and you'll see what they're doing. There's visibility over here where you can actually, I generally leave everything hidden so that then when you click on a toolpath underneath the setup, you will see the path of that toolpath. So that's how I deal with that. So let's look at each one of these setups. I'll go through very quickly each one, and then we'll go into depth on each. So this is a neck fixture, basically just a piece of MDF. This is 30 inches long and it's 5 inches wide and 3/4 inches thick. Basically what I do is I like to have these on top of my spoil board so that I kind of preserve my spoil board, and also I can surface this area and make this perfectly flat. And then I will actually tape my parts to this fixture. So let's look at what's inside this neck fixture. Basically, I'm going to cut 2 index holes here, and that's to be able to mount this or take it off my CNC if I'm doing different things. Then there's a facing toolpath. Like I said, this is going to flatten this fixture. And then the last thing I'm doing is a set of lines. I've got center lines, horizontal and vertical, and then I come in from each side and draw little 1/2-inch lines with, I shouldn't say draw, they're actually cut, with a V-bit, just a little bit down into the MDF. And that way I can just kind of by sight center a piece on this fixture, whether it's a neck or a fretboard. Okay, so that's the neck fixture. If I activate the next thing, we see this big block. This is actually the neck stock, and I modeled that. And this is one of the things I want to drive home in this video, is that I now started using this manufacturing model, and I really like it. And I suggest doing the same. What that is when you create a new manufacturing model, by default, you will get the model that you've been using in the design side, which is this right here. You can see that it shows a very recent version of the model. And then you can add components underneath, either inside the model or outside the model, which I chose to do for different things. So I've got one for my neck stock. I've got another component, which is my fretboard stock. I've got a kind of a conceptual thing that I call a full paddle, which is a flat surface that I want to rough and smooth so that I can start finishing the headstock. This is another one called a mini paddle, which is the backside finishing of the headstock. And this, let's see, this last one is actually the neck fixture that we looked at a little bit ago. Okay, so that's how I'm doing things when, for instance, we go to one of these setups and we see a big block. That's not Fusion generating the stock. That's me modeling the stock in a manufacturing model and then including it in the setup. And I'll go to detail on that. But let me just quickly go through what this neck stock indexing does. Basically, it just drills holes about a 1/2 inch deep in the neck stock. And these are going to be the holes used when flipping this part. So this setup is actually going to get run 3 times. I'm going to run it once on the fixture itself so that there will be a 1/2 inch hole in each end, right in the middle of the fixture. And then I will actually run it on the top side of this stock, going down a 1/2 inch. And then I'll get a couple of 5/16 dowels. I'll stick it in the hole. I'll flip this part over and put it right on the fixture. And then on the bottom side of this, I'm going to go ahead and drill 2 more holes. So instead of defining individual setups to do those 3 things, I just opted to run this 3 times. So when I call up this setup, I will first index off of the fixture plate and complete the single toolpath that's in here, and then do the same on the neck stock, and then flip the neck stock over using pins and do it a 3rd time. So just some background as far as the index holes. I always use the center of the piece. I've seen people do other things. I've run into problems in other things. It's really easy on a piece of stock to draw a line very close to the center and position this on the neck fixture. And once I've set up my coordinate system on the neck fixture, I'm not touching my Y coordinate again. It's always going to be in the middle, whether it's the neck fixture or whether it's a piece of stock. So that works out well for me. So I'm going to actually run this 3 times, once in the fixture and on each side of this neck stock. And then we're going to cut into that stock, and the initial cuts are going to be on the top side where the fretboard is going to get glued. So we're going to end up cutting a truss rod slot, this neck, heel pocket, and we're also going to do this, basically I call this the paddle, this oversized headstock, cutting that flat. After that setup runs, I will glue the 1/8 inch decorative headstock cap to this paddle, and then the whole piece is going to get flipped upside down, and it's going to have this headstock cap. It's not going to be textured in. It's probably just going to be roughed out to the size of that paddle. But then we're going to cut the backside. So those are the operations. One thing to think about is the the work coordinate system. So basically, when I start, I'm going to index off, basically, the first time I run this, I'm going to index off my fixture plate. But then I'm going to index my Z off of the top of this neck stock, and then I'll run it a third time after flipping the neck stock over. So I'm always in this coordinate system where I'm referencing the top of the stock. When I go to the neck top, I stay in that same coordinate system. So effectively, the software doesn't think anything's been flipped. And then when we go to neck bottom, that's when we're going to flip. But that's when I'm going to index off of the fixture plate, which is essentially indexing off the bottom of the stock. So that way, you know, if this stock isn't exactly as I modeled it, and it never really will be unless you surface it yourself on the CNC, everything will fall in place because we're indexing off the bottom. Okay, so let's go into detail on each one of these tool paths, and we'll edit the tool paths that are of interest, and I'll show you some of the more important things. Okay, so fixture holes. This is a boring operation. So if I double click on this, you can see over here on the right, this dialog box. If you extend this, then you've got wider tabs, and you can see not just the icon in the tab, but you can see a verbal description of the tab. So I'm starting with a 1/4 inch bit, and I'm just cutting 2 holes that I select with this geometry tab. I just went and selected here and here. Those are the 2 faces that are going to get cut. So that's pretty straightforward, but the height, I want to set the top of the cut to the whole top, which is right here on the fixture. And the bottom, I'm going to set to 3/8 of an inch below that. So I don't want to drill all the way through this 3/4 inch piece. I just want to do half of it. So that's why the bottom height is the top of the model, which could also be the whole top, you know, basically this surface right here, down 3/8 of an inch. So that's basically that tool path. Let me back up and also show you the setup. So if I double click on this icon, this is pretty important. Well, it's crucial to get right. So, you know, we're setting up a work coordinate system. To do that, I wanted to select an X and Y axis. But first, you generally want to go to stock, and you want to figure out how you want to either model this stock yourself or have Fusion kind of figure it out. All of these things, except from stock, Fusion is figuring out based on the model that you're using in this setup tab down here. But in the case where you use stock from solid, that means you're actually modeling it somewhere, and then you've got to tell Fusion in this line right here, this is the actual stock that I want. So again, I had just modeled a very simple, you know, slab of MDF here. You know, here are the sketches. If I turn these lines off, this is the sketch I used to model this. You know, couldn't be simpler, just a rectangle. And then it was extruded to 3/4 of an inch. And again, I did that inside this manufacturing model. Okay, so that's what this neck fixture setup has in it. Let's go back to that. So it's important, you know, when you set your work coordinate system here, if I unselect this, I want my x-axis. In this case, my machine, the long axis is x and the short axis is y. I want my x-axis moving, you know, from this starting point down that way. If it doesn't show up right, I can flip it using this check mark. But it's also going to make this, you know, triad relative to the x. So it'll end up flipping the y or z when you do that also. Okay, so here's where you would select your y-axis. I'm just going to select this edge. And you can see I actually want to flip that with the check mark. Okay, so now that I've got the coordinate system set the way I want, I also want to set a box point. So this is saying, where do you want to set the origin? You could set it based on something in the model, but I want to physically click on something inside this stock that shows where I want it to start. So if I click on this point, this is the y-axis center, and you can see that the Z is now at the top of the stock. So I'll use my little reference plate, I'll put it right on the top of this stock and zero out the Z. Once I've got the X and Y set here, for this setup, I'm probably not going to touch them again because I'm always going to start from this center point. Okay, so that's set up. This is the stock. Make sure that if you model something that the stock matches, what you think it should be, 30 by 5 by 3/4 inch here. And that's my neck fixture, which you see over here in the manufacturing models tree. So I can OK out of that. So you would do that before really going into any of these individual setups. And since I made some changes here, you can see I've got these little orange icons. So if I right click here and generate, all of these toolpaths are going to get regenerated because I messed around with the work coordinate system. Okay, so fixture holes we covered. We're just using a bore operation to do these two holes. I don't think we got into the height of that. So the height I want to set to 3/8 of an inch below the model bottom. Remember, the model was this piece of stock. So if we let this toolpath run, you can see, if I do a side view here, that this bit is actually going to go quite a bit below the stock and cut into my spoil board below, which is what I want because I want to put dowel pins in, and so this thing will not move. So I'm in a simulate mode here, and this is the speed. So I'm going to slow the speed down, and here you can see the bit actually penetrating through the MDF into essentially my spoil board table. So that's what I want. By the way, you're seeing green here. I'm in comparison mode, which I really like to use in this stock. There are different modes where you can set it up, to see what it's cut in different ways. The comparison mode I think is the best because green means everything's been cut down to the model. Red means you've cut too far into the model, and blue means you haven't cut far enough into the model. That'll be a little bit more evident in some of these other toolpaths. Okay, so the second toolpath in this first setup is a facing operation. So I'm going to go ahead and double click on that and open up the dialog boxes. Here I've got an 1.5 inch wide surfacer, which I use, for spoil board surfacing. The geometry couldn't be simpler. You just click on, the face that you want surfaced. And then in the heights tab, you are controlling what depth you want this to go to. So I'm starting here. My top height is where the cut will start. I'm starting at stock top, and then I'm going to go from model top. I could have picked stock top here too, basically the same thing. Oops, let me get back in there. You'll learn very quickly not to hit escape in these dialog boxes. Okay, back to heights. Down here, I set this, what are we doing? Facing. So I set this to 0.0125. So I think that's about a 64th of an inch. So I'm not taking much material here, but I just want to take enough to get a flat piece that we can, tape to. The passes, this is sort of interesting in that I changed a couple of things here. I did a pass extension of 3/4 of an inch, and I did a stock offset of 1/4 and a step over of 3/4 of an inch. So let me get out of this and I'll show you what that did. The pass extension basically allows this toolpath to go beyond our piece of stock. And then when it turns the corner, it's out of the stock. The overlap, basically, we're doing basically half width of this bit, which is fine for MDF. You know, if this was a piece of wood and I really wanted to finish it nicely, I wouldn't do half the bit width. I'd do quite a bit less. So that's the those are the two parameters that I changed. The last one, basically, I'll show you if I go back in there and change passes. Stock offset by default is 0. So now when this gets generated, you'll see that this bit, the center of the bit, is going to move right down the piece. That's all well and good, but one thing I noticed when that happens, I'm going to simulate that toolpath. And this is going red, by the way, because this is cutting into the model by a 64th of an inch or whatever it is. So in this very last pass, you'll see that the bit was just really aligning to the outside of this board. I wanted it to overlap a little bit. So that's why I came in. Let me pull up the dialog box. And I did a stock offset of 0.25. So that's starting the bit a little bit inward from where it initially was. And now if I simulate, you can see that that bit is, well, when it ends up, it's going to overlap the edge a little bit. You'll see here's its last pass, and it's, you know, outside of the piece of MDF. Okay. Now that I have this surfaced, the last toolpath in this neck fixture setup is I want to draw some lines on here with a V-bit. So I've got a 45-degree. Fusion actually calls it a 22.5, looking at half of the bit, V-bit on there. So I'm going to just etch lines into the MDF. They don't have to be very deep. The geometry that I'm using, this is a trace operation. So basically the way I think of trace is you can use a sketch or parts of your model and just have your tool move along that sketch. So in this case, in neck fixture, I have all of these lines right here, and I've defined these lines. I put a center line, horizontal and vertical, and then I came inward half an inch from each side and from the two ends too. So that way, you know, I can very quickly get a center based on the size of the part. So the only interesting thing here is how you set that depth of trace. You can move the sketch down. I'd prefer not to move the sketch around because it's at the top of this piece of MDF. So what you can do is actually in the passes tab, use this axial offset. This is a offset from where the sketch is. Keep in mind the sketch was on the very top of this fixture, and then we cut a 64th away with the facing operation. So I want to keep going a little bit beyond the facing operation, which is what this 0.025, so 25 thousandths from the original top of the spoil board. So that's how you would set your depth in trace. You'll notice if you try to do it in heights, there's not a top and bottom cutting height in trace. Trace assumes that you're going to go to, you know, whatever geometry, wherever that is in the model. But again, you can change the depth right here with your axial offset. Okay, so that's the fixture. That's pretty simple, at least compared to some of these other things. Okay, so now I'm going to activate the stock, neck stock indexing setup. And so first, let's go see how that is set up. You know, it's got the same work coordinate system. So the Z is on the top, the Y is centered on the piece, and the X is on the end of this piece. The The stock, I am using stock from a solid, and it is this neck stock that I modeled. Basically, when I did the glue up of this neck first, and then everything else, kind of followed that. Basically, I had a piece of maple, and then I wanted to do a wider headstock than the piece of maple that I have, so I actually glued these ears onto it, and then modeled this stock, to match what I had physically glued up. So here's my stock size, 29.5 inches long, a little bit shorter than the fixture that it sits on. Stock depth, well, I would call that width, but anyway, stock depth is this distance across on the paddle here, on the oversized area for the headstock. And then the thickness is 1.75 inches. Okay, so that's how the setup is. Set up. So the only toolpath in this is this holes toolpath, and this is a boring toolpath. So basically, you can bore a hole as long as your hole size is greater than your bit size. So I've got a 5/16 hole defined. I actually defined that when I was modeling this neck stock. That's in the neck stock sketch, and then when I extruded, I didn't bother to extrude the hole. So I didn't even have to extrude the hole by itself. So for this, the geometry is just selecting these hole faces. Another thing you can do is you could select one of them and then use this check mark, which will select all holes of the same diameter within your model. It'll save you a click. Okay, so for heights, I don't have a bit that is going to do a hole 1.75 inches and then also into the fixture, because the whole purpose of this hole is to index this part to the fixture. So that's why I'm kind of cheating and running this 3 times, and the depth each time is going to be a 1/2 inch below the top, wherever the Z starts at. So again, I'm going to run this toolpath with just this fixture here, and it's going to go a 1/2 inch into the fixture with a hole. Then I'm going to select the bottom of this neck stock and put that on the top, drill a hole by running this toolpath, or drill 2 holes by running the toolpath again. And then the third time, I'm going to actually index this. I'm going to get 2 dowels, flip this over, put it into the fixture, index off the top again, and drill 2 more holes. And those holes will be used when we flip the part to go to the neck bottom. Okay, so that's all there is there. That couldn't be more straightforward. I'll collapse that, and now I will activate the neck top. So now in this case, let's see how this setup is configured. Same coordinate system. When we go to stock, I just kind of took a shortcut and I said I want the stock from the preceding setup. So I'm using the same stock that the neck indexing stock used. Okay, but now here in the setup tab for the model, I want to actually use parts of the real guitar model here. I want to use the neck. So that is inside, well, it's in my manufacturing model. Let me back up for a second. So right here, you can pick default, which would be the model that you were modeling in the design workspace, or you can pick any of your manufacturing models. You can actually have multiples. I just have the one here. So I am picking from my manufacturing model, which is what I want, and then this next field shows me, how many components do you want to model? Well, I want my neck component, which is inside this SE-24 model. See how neck is highlighted here, and you can see it over here in our workspace. And also this thing called a full paddle. So this is really just kind of a conceptual thing where I modeled, instead of this, limited, this curvy headstock, I modeled all the way out to the edge of the stock. And I want the CNC to clear this out. Two reasons for that. One is I want to glue a headstock cap on top of it. And, and once that's glued, then I want to cut into both of these. The second reason is I'm actually not going to profile parts of this headstock, like here, here, and here. I'm going to do that on a router table using a fixture that I will model on the CNC and then just double stick tape it. I tried to get it to work with just two setups here, and because this part is angled, there are parts of the model that I didn't have access to. And I can show you a little bit later. You can figure that out using the accessibility tool, which is, I think it's here, Inspect Accessibility Analysis. Will actually show you, if you're cutting from a particular side, whether you can access some of your 3D geometry or not. It'll be red if you can't access it. So anyway, I decided after a little bit of struggle to cut these three contours or these three profiles on a router table. But I do want to do this area and this whole neck transition on the CNC machine. Okay, so we are in our neck top. Oh, and by the way, one thing that I learned, well, two things. If you right click on one of these setups, you can choose an associated named view. And so, any of the views, top, front, bottom, right, etc., you can associate with that setup. I made two other views. I call it CNC and CNC flipped. And this is where I'm usually standing on the CNC. So I want that view in particular when I'm modeling this stuff. So that's the view that you're going to get when you activate one of these setups. Second thing is, since each one of these setups can have different stock, it can have different components within the model, I highly suggest you use this synchronize field. I turn all three of these on, so I am synchronizing the view with the active setup. The active setup has this little fisheye selection. I'm synchronizing visibility. So if I have particular pieces of this model, in this case I have the neck and this paddle as part, whatever I have in this setup. Let me just pop it up. Whatever I have here as this model, that's what's going to show up when we go to these different setups. So in this case, we're just seeing the stock. In this case, we're seeing the actual neck plus this conceptual paddle. In the bottom, I actually enabled viewing this headstock cap. And that's the reason why I had to make the headstock cap its own component. If something's just a body, you can't really control it with this synchronization in CAM. So back to the neck top setup. I'm going to activate it, and you can see I've got my neck and I've got this conceptual paddle here. Also have some sketches showing, so I'm going to go into, actually going to click on it. Look over here in my manufacturing model. It's saying that sketch is in full paddle. I'm going to hide that sketch and then collapse this down and collapse this original model down. Okay, so now we see the the PRS neck plus this extended paddle. Okay, so let's open up. I'm going to close the manufacturing model and let's open up the setup. Okay, so this one's a bit more complicated, and let's walk through these one at a time. So if I double click on our fretboard index holes, you can see that I've got a 1/16 of an inch bit. I'm doing a drill operation. So in this case, I didn't have a bit that I wanted to use that was less than 1/16 of an inch. So instead of boring, I'm drilling. So drilling means that hole is going to match the size of your bit. It's going to go straight in. So in these 1/16 of an inch holes, I'm going to put a little bit of a side marker plastic. And I'm also going to do similar holes in a fret slot itself and go all the way through the fretboard so that I can perfectly align the fretboard to the neck when gluing, and it's not going to slide around when I start to clamp it down. So that's the purpose of those index holes, tiny little holes there. Selected the same way we selected the flipping index holes. You just click in, in the hole face itself. The height for that controls the depth of it. Well, actually, it doesn't. It's going to the hole bottom. So I played around with the height when actually modeling these holes, but you can do it either way. One thing to be careful of is if you go too far with this, it'll actually pop through the neck. Oh, and these positions, if you were to see these in the fretboard, this is at fret 1 and this is at fret 24. And these holes are small enough to where when you put the fret in, you're not going to see the hole. And I'm thinking I can actually pull that plastic side marker dot out after I've got the whole thing glued up. So I won't even have to remove that from the fret slot. Okay, so that's the first toolpath within this setup. The second toolpath is going to cut this truss rod slot, and it's also going to cut the extension of the truss rod slot out here in the headstock. So let's see if there's much of interest there. Basically, 1/8 of an inch flat end mill. The geometry, I selected the bottom. I came in here and selected the bottom of this fretboard, I'm sorry, truss rod slot. Now here we're not seeing the slot because I've got this paddle defined. So you can either drill down through it holding down your mouse button to select, or I think a better approach would be to go to the manufacturing model and then just to temporarily hide this full paddle. And now we can actually select the bottom of that. So that defines our two truss rod slots. The heights should be set to the bottom of those contours. So the top is our stock. The bottom is actually the selected contour. So I selected the contours on the bottom, so then I can use the bottom to establish the height. I think I've had pretty good luck with the truss rod fitting in these slots, but sometimes you have to cut this again. So what I would do is I would actually make, I'd right click and I would make this its own NC program, and I'll get into these in a little bit. But I would isolate this toolpath by itself so that I could run it separately from all the other stuff if we need to overcut a little bit. And I guess that's one thing of question here, is that in passes, I didn't have any negative stock to leave. Basically, if I want to overcut something, I would put a negative stock to leave on the axial on the sides. You can see radial, radial is the bottom, axial are the sides. So I don't want stock to leave here. And if I want to overcut, I would turn stock to leave on and have negative values for the axial and possibly for the radial as well, depending on how well that truss rod sits in there. So anyway, neck contour. What I did there is I actually wanted to just do one pass around the neck, including this little section right here, and actually leave stock because we're going to cut that all the way to the bottom from the other side. And this little face is going to get finished. It's final finishing cut when we're working on this paddle. I'll preview that. I'll simulate that. So here's the toolpath, just going around the neck once. And you can see it's all blue, so it hasn't cut as far as it really should to expose the model. Okay, so that's the neck contour. That's pretty easy to set up. We've got a 3/8 inch flat tool. Our geometry, I just clicked. One of the tricks of picking geometry is I like sometimes to hold down the Alt key, and then you can select individual edges. You have to be careful to get them all. If you get an error message, generally it's a missing edge like that right there. So if I do an Alt click, I'm getting that edge. Let's see, I missed it on this side too. Alt and edge. I'm surprised that didn't generate some type of error. The second thing you want to be aware of in contours is these arrows should be on the proper side of the contour where you want to cut. In this case, I want to be outside. If I click on this, you can see it swaps the arrow to the inside profile. The height here, I just went down 1/8 of an inch beyond the top of the stock. Passes, I'm doing this in a single pass because I've got a 3/8 inch wide bit and can certainly handle 1/8 of an inch cut at a time. Okay, so I'm going to OK with that. Let's see. So heel roughing, it's going to be this section right here. So I'll double click on that and we'll look in the dialog box, staying with the same 3/8 inch flat tool. Geometry, I selected this area. I also selected the same area for my stock contours. If you're having trouble with your adaptive, and let me simulate the adaptive, not boring down properly. So this is proper. This is doing a helical cut to get down to the level of cut that I want to do. Then when it does the first pass here, it's going to do this helical cut again. If you're having trouble with that not showing up, if it's just starting to plow into this material without doing a helical cut, generally when I get that, I'll let this finish here. When I get that, it's easily fixed by adding stock contours. So stock contours basically means this toolpath is going to be restricted to this particular area instead of the whole stock. The adaptive 3D toolpaths like to just cut the entire stock if they can. So here you're restricting it. So you're showing it the boundary to do machining in, and then you're showing it the boundary that it needs to stay within. That seems redundant, but when you turn both of them on, sometimes adaptive starts behaving the way it should. Heights, we're going down to the model bottom, which is this surface right here. Passes, I've set our pass level, which you would do with this maximum roughing step down, to 3/8 of an inch. See if there's anything else of significance down here. Oh yeah, we did leave stock, so 20 thousandths on the walls and on the bottom of this pocket because this is a roughing operation. So this is going to be followed up by another operation essentially using the same geometry. So this is now a parallel finishing. It's using the same tool. It's going to go down to the depth of this pocket right off the bat and then start finishing it. So you can see in the geometry, we've also selected this area to be machined. And that's pretty much all we did. I didn't do multiple depths. I didn't do stock to leave. I wanted to go all the way down. So if we simulate that toolpath, you can see that the roughing operation is finished. And if we come in and smooth it, then we're exposing green. Okay. Now I'm going to go back to the roughing operation because I had a little bit of problem with a tiny little bit of stock being left on the edges sometimes. And although that's okay, it can kind of blow out, and I didn't really want it. So I went into the roughing operation, and in the geometry tab, I added a negative additional offset, which is going to push the toolpath out when it can. It's not going to bump into an existing model surface and crash into it. But when it has the leeway of doing that, it'll come out. So I did 3/10 of an inch, and that got rid of, well, let me set this back to 0. I can show you what it got rid of. If I've got no additional offset, which is the default, when I simulate this toolpath, you'll see what I'm talking about. Let me speed this up a little bit. So it should leave, you see how it's leaving a little bit of material here on the edge, which is okay, but then, you know, the roughing, the smoothing bit, the ball nose bit is going to bang into it and potentially knock out a big chunk. So again, what I did was in roughing geometry, I set that to a negative 0.03. I think that's what I did. You know what? I'm just going to do an undo and hope that this is the value. Okay, that was the value. I had 3/10. Okay, so I got it back by simply doing an undo. Okay, so that was the roughing. We already did the finishing. Now this is pretty interesting. This is the paddle rough out. So I want not just this headstock to be roughed out, but this wider area of the stock to be roughed out and smoothed so that we can laminate a piece on top of it. So let me double click to open up the paddle rough. Same 3/8 of an inch bit is being used. In geometry, I did a machining boundary, which I just selected this paddle area. Stock contours also selects that same. And again, that's the good trick to get roughing to operate properly. So now let's simulate this, and you'll see that the toolpath is going to, bore down with this helical approach. And now it's roughing. I think I've got a 3/8 inch as my maximum step down, so that's going to create 3 different roughing passes. So this is on the 3rd pass right now. And you can see it's got this series of step downs to rough out this paddle area at its 10-degree angle. Okay, so this I haven't talked about before, but one of the goals of this toolpath is to leave these index holes, leave enough meat around the index holes so they're still functional. They still can be taped when they're flipped over. I can still put a dowel in here. So basically, when this is all done, and we're almost done with it, we need a finished operation. I'll show you how it's going to get flipped. So let's move on to the paddle finish. Just to back up a second, in the roughing operation, I may have done an additional offset here. I did. So same issue as when we were doing down on the heel. It might not have gone to the edges of that piece of stock. So I did a negative additional offset, which is pushing it out a little bit in this case. Okay, so let's look at the paddle finishing. This is now this is a parallel toolpath, so it'll go back and forth in a parallel manner. I did not use a ball nose here because I'm going to go up and down this paddle along the angle, and if you do that, a end mill can function pretty much the same as a ball nose, but the reason that in this case it actually functions better, let me simulate the toolpath and show you. When it does the finishing here, it can actually get into the, oops, sorry, I zoomed in a little bit. Let me back that up to show you this little face that the headstock cap is going to glue against is blue because when we did the perimeter around the neck, I left some material, but now that the finishing is starting and I don't have a ball nose, I have a straight end mill, I can get it right up against this corner. Now, to get the end mill to go in the direction that we want it to go, let me slow this down. This parallel toolpath, has a 0 angle. I don't know how it figures that out, but it could have been going in the opposite direction, across this way. So if you need to change that in a parallel toolpath, you would do that in passes, in the pass direction right here. So in this case, it does default to the way that I wanted it to go, but if it didn't, I can change that to say 90 degrees, and that would fix that. So no stock to leave, since this is a finishing toolpath. We're going right down to the model. And our heights is basically going to be defined by the model. Stock top, and in this case, it's going to finish it right to this paddle, as I call it. Okay, so let's go up to the neck top. Select the very top, and now I'm going to show you how I like to review this before I finalize it. So if you can simulate each one of these individual toolpaths by selecting it and going to simulate, or you can simulate the whole setup by clicking on the setup and then simulate. If I hit the play button, it's just going to run through all of these. Instead, what I like to do is go to this info tab. This is going to show you the name when we start going, the name of the toolpath here. Here it is. Here's the one that's about to be executed. So if I use this button, go to next operation, this will change, and the operation that's described right here is going to be finished. So our fretboard index holes are now cut, and our truss rod slot's about to be cut. I'm going to go to next operation, and it takes a second here, but now you can see that that is cut. Okay, so the next operation is our neck contour. I click on next, that is now cut. Let's see, next up is heel roughing. So that's down on this end. That took a few seconds to simulate. Then this is the heel finishing. So we can see that everything's turning green here, which is nice. That's our finished model being exposed. Next operation is the roughing of this paddle, which takes a little bit of time. And then when that finishes, we'll go on to the last toolpath, which is our finishing toolpath. Almost done here. Okay, so I do a next operation. This is now, when this finishes, this will be the end of our finishing pass. So that's all of the toolpaths in this neck top setup. Now let's go on to the next setup, which if I collapse these down, I'm going to collapse down the manufacturing model. Our last setup is the neck bottom. So first I'm going to activate it. That will flip the part, essentially. And you see we've got our work coordinate system on the bottom now, which is what we want. So let's look at that setup. So I'm going to double click. The stock was from preceding setup, same stock. But the work coordinate system was different in that we dropped the Z down to the bottom of the stock instead of the top of the stock. And then I'm still using manufacturing model 2, and these are the components within the manufacturing model workspace here that I want to be modeled, so that they can be cut. We've got the neck, we've got a mini paddle, which is a smaller version of that paddle, and you can see I want it to start in the upper section of the headstock because I want to cut this out on CNC. This is the only part that I'm going to cut on a router table, just the edges of the headstock here. So that's why I've got 3 components set up for my model. Neck, mini paddle, and the headstock cap. If I OK out of here, you'll see I want that on. That's glued on between running the neck top toolpaths and the neck bottom toolpaths. And I want it glued on because I'm going to cut this, this surface right here, and I want that to be part of it. Okay, so that's the configuration of that setup. Here are the individual toolpaths. So the first one is a heel contour. And the reason I contoured just the heel is I actually want a tab to keep this neck attached to the part that is indexed to the fixture. Just for safety's sake, these are all being attached by two-sided tape, which works great, but if something goes wrong, it's nice to have that index pin in there so that this thing doesn't pop off if it's taped, it's taped holding. So if I simulate this, you'll see this first toolpath is the heel contour, and if we look at it this way, you can see it's going to start stepping up here. So I have defined a tab. So this is an interesting setup. So I'm going to double click and open it up. I'm sorry, I should have said toolpath. The whole thing is a setup. This is a toolpath. So I'm using the same bit that I'm using a lot in these toolpaths, this 3/8 of an inch flat. The geometry, all I selected was this little edge right here. That's the only contour I want. The reason that I didn't add these other contours, which will eventually get cut, is they're at a different elevation than this. I wanted this elevation because I don't want that tab to get cut through, so that I'll show you when we do our next contour, this part's not going to be included in it so that we don't lose that tab. Okay, so how do we define the tab? That's a check mark in the geometry setting. This chain is just this line right here, so that's our geometry. I did a tangential extension distance so that when this is cut, it's going to extend beyond this short line a little bit. I made a pretty good sized tab. So I turned tabs on. I made a 1 inch wide tab, 1/4 inch tall, and then I actually came in and positioned the tab myself by establishing a point right here. Otherwise, you can have this basically a distance for tabs. We don't need that because we only need a single tab here. So here is our tab position. Okay. The heights, we are going to go down to the selected contour, which is right here. That's as low as we want to go. And again, because of the tab, it's going to step over the tab. Passes, I do want to limit the passes. Let's see, step. Okay, so here's our multiple depths. I'm coming down by 1/8 of an inch at a time. And this is a little confusing for me. Finally, I'm understanding this. I want to have roughing passes on so that the multiple depths are considered roughing passes, and there's an automatic finishing pass, just one, unless I select multiple finishing passes over here. So what I try to do on a contour is to do a series of roughing passes and then a final pass at full height. So in order to do that, you want to turn on roughing passes, and you want to set, your step over. I just set my step overs to 1, and here's my multiple depths, so 1/8 of an inch at a time. So let's go ahead and simulate that, and we will see that will step over this tab pretty soon. There it is. And you see it's also getting extended way beyond the geometry of the neck, which is good. Okay. And in this case, you might see actually better information by just clicking here and seeing the toolpath. You can actually see where it steps up for the tab. Okay, so the very next thing, I want to cut everything but that area. So I'm doing another contour operation, and same tool. I come in with geometry and I do an alt click on each one of these edges, but I didn't include this one. So you can see this is actually going all the way around, and I actually, alt clicked on this edge of the headstock cap. And I also want to do an extension here. So in passes, where is it? Is it in geometry? Oh, I didn't do a separate tangential end extension. I may actually want to do that. Let's try that. Let's extend that by 1/8 of an inch. So now our toolpath goes a little bit beyond. This could be a problem if it smashes in here, but let's go ahead and see. Oh, that did create a problem where the other side didn't get selected. So that's probably why I didn't do a tangential extension. So I'm going to undo that and then just click on this neck contour, and you can see now the toolpath exists on both sides of the neck. And you can see here it's stepping down by 1/8 of an inch. If I was to highlight this one at the same time, these kind of align, but they're cut at different times. So I'll just click on the neck contour here. Okay, so we're just doing a quick contour to kind of, cut this edge out. And then this one's the biggie. This is a single roughing operation. Let me go ahead and simulate it. This takes a long time to generate, and it's going to take a long time to cut, 45 minutes, and it takes a long time to simulate too. So I'm going to speed this up, but you can see it's starting here in the paddle, working its way down to the heel, and cutting quite a bit. I'm letting it cut 3/8 of an inch, which is the diameter of the tool, because it's using the side and just cutting a little bit at a time. So here it's, I think, continuing to cut. You can see how pokey this is. Let me speed it up a little bit. So I'm just going to stop the simulation because it's being so slow here. But let me go into the toolpath itself. I'm using that same 3/8 inch flat end mill. The geometry, I picked a silhouette here, which I think works well for the machining boundary. So basically anything that's projected straight down from all of the pieces of this particular model for this setup creates this silhouette. Tool containment, I want the tool outside the boundary. Yeah, I guess that's working well for me. And stock contours, let's see, if we turn off the geometry and say none, the stock contours are basically that same thing. I selected the entire model and the paddle. So let's turn the silhouette on. I'll uncheck this. And I guess you don't see a silhouette, but it's whatever this is projected straight down. Okay, so stock contours back on. The height of our roughing is not really settable. It's just set to model bottom. Passes, the same as any other roughing that we've done. It's the minimum step down, or the maximum step down is going to be 3/8 of an inch. Okay, so that's the roughing operation. Now, the finishing operation is pretty interesting. So I used a parallel finish, and basically I'm using a 3/8 inch ball nose for this. The geometry, I did the same trick. I'm doing a silhouette of all of the model pieces. Contact point boundary is very important to, I'll let this little pop-up show you what it is. Very important to select that, because basically when we come down over the side of the neck here, I want the tool to go below or outside of the model so that we can cut all the way to the edge. if that was turned off, we wouldn't get very close to this edge. Okay. Excuse me. So now I've got the model turned on. I actually selected the faces that I want to be part of this model, and I found that to give me to actually fix some issues where basically the finishing was dropping off the edges here. No, actually, let me take that back. This avoid touch surfaces, if I turn that off, and let me go ahead and show you the toolpath here. You see how it's now dropping off the edge and plunging all the way down, and it's doing the same here, and it's doing the same here. I wanted to prevent that from happening. I don't want the tool to end up, the ball nose to be finishing this part right here. It's already finished. So the way I got Fusion to prevent it from doing that is, where was it? In our geometry, I went into avoid touch surfaces, set them to avoid, and then selected all the surfaces that I want specifically to avoid. And essentially, these are all the surfaces that are either pre-finished, in this case around the heel, that is the case. So I'm just clicking on all of those. And also with this paddle area, you know, I don't want it to waste time finishing these areas because they're all going to get cut away on the router table. So you can see now down in the dialog box, I've got 9 faces to avoid. And so if I do an OK, see what happens here. See how the toolpath does not drop over the edge. But it does drop down on this edge because we have contact point boundary turned on. So we're allowing it to get down far enough. You'll see this when I simulate it. So that we should pretty much see almost all green, or hopefully all green, right here along the edge. Again, this is being very slow to generate, but you can see it's not doing much of anything right here. So I stopped the recording there because the simulation was being so slow, and I kind of figured out why. I had the accuracy set all the way up, which in these complicated toolpaths will cause Fusion to be very, very slow simulating this. So I went 1 notch down in accuracy, and now if I hit the play button, you can see it's a lot zippier. So if we zoom out, you can see all the stuff that's being finished here. So basically the paddle, the transition between the headstock and the neck contoured up to this flat area of the heel, and all of that flat area as well. And that's all done with a ball nose bit. So like I was saying, because I did contact point boundary, this ball nose bit is allowed to essentially plow down a little bit into the fixture, but it is finishing this part all the way down. So I'm going to stop this simulation before it finishes, and let's see. So again, I'm going to do what we did on the neck top. I'm going to click on the top level on the setup, do a simulate, and then just go through one by one with this info tab open, and you can see, okay, here's our heel contour, and go to the next. So that's just essentially contouring the edge of the heel, leaving our tab in place. Go to the next operation. That cut our contour around everything else, the transition area and the sides of the neck, and you can see that's finishing those parts of the heel as well. They're showing up in green. Let's see, the next is going to be the big adaptive clearing, which might take a minute. And then the next is going to be our finishing operation, which is also lengthy. So another thing to check before you go to CNC is to see what this part looks like with all of the cuts that happened. So this is a little tricky, but I'll show you what I do here. This finishing is being real pokey here. Oh, there we go. Well, I'm going to stop it. Okay, so what I would do is this. I would say, okay, I want to see the top cuts, flip it over and see the bottom cuts. So we've got these two setups that control that, neck top and neck bottom. I can only activate one of them at a time, which means, you know, these paddle helper surfaces and, you know, the stock and the model, all of that, we can only select one of these two environments to see. So I'm going to select the second one, okay, as the active one. But that doesn't stop me from selecting both of these setups and then going to simulate. Okay, and then I'm going to go next operation through simulation, but I probably should flip this over manually. That did the little index holes here so that we can see what's going on this side. That's our truss rod slot and truss rod access. That's the very shallow contour around the neck. This is the one I really wanted to see from the other side because I want to make sure that this area is preserved and isn't going to snap off the same down here when we eventually cut that roughing area. So we're still on, let's open up info and see what we're on. We're about to do the heel finish. So this area should turn green down here. Now we've got our paddle rough. Okay, so this left this area with our index hole, so that looks like that's plenty to flip this part over. Now our paddle finish should not, you know, eat into this area either. So now, before I go on to the next one, I'm going to manually flip this piece over, and then we'll start up again. So now it's going to move, it's moved down into neck bottom. If I had opened up these toolpaths, you can see the highlighted one is the one that's about to be cut. But we can also see it over here in our info box of the simulation dialog. So here's the heel contour. This is what I specifically wanted to see. After that's cut, I want to make sure that this tab is actually attaching the neck to this area, and it is. So I would make sure that this is taped here and this is taped here well, very well. But, you know, we want this piece to stay on just for some little extra security, basically. Okay, so go to the next operation. That is our side contours, our neck contours. This is showing up as red as if it's being overcut. That's a function of just another piece, that paddle, showing up in this setup because we had two setups at once. I'm quite sure that's not being cut if we had just done a simulation of the neck bottom. But let's continue on. So this is our adaptive clearing, which is going to take a while. And I think we're going to see this red area actually get fixed when we go into the finishing. Okay, so I'm going to go to the last toolpath, which is the finishing toolpath. And let's see, as the ball nose steps down over this transition area, it does in fact change that to green. So once this finishes, we have both sides of the neck cut in a simulation. And before I exit the simulation, I can just orbit this around. You're seeing Fusion is kind of choking on this again. I'm going to stop the recording and come back when that's done. Okay, so the finishing operation has completed. You can see that our transition areas are nicely finished. Let's also examine up here. Our headstock is still attached to this block, which is great because we don't want this vibrating as it gets cut. And I think this is going to be enough, you know, with this surface being taped down right here to stop that vibration. You know, if not, you could make a little wedge and stick that wedge, you know, double stick tape that wedge underneath as well, which is probably a good idea regardless. And here is our attachment down here to this block as well. Okay, so then we can exit our simulation. So basically that's it. It's a little complicated, but I decided to go with just 2 setups instead of a third setup that would allow me to flatten this on the piece of MDF on our, you know, our fixture. Instead, I thought, you know, why not just cut this on a router table using a nice little template or jig that I will cut on the CNC. And that template or jig can include the tuner holes as well. So I hope you enjoyed it. These cam tool paths I've worked on quite a bit, but again, they need to be tweaked for your machine. Don't just use them as is, because your feeds and speeds or your direction of X and Y can be very different. So this is really just to give you an idea of, you know, how I did it. All right, signing off.